Okay. So, this lab, Experiment 8, Quantitative Precipitation. So, in the normal lab, you would take these hydrates and you would make a product from them, and you would try to analyze, predict, understand what that product was. So first up, hydrates, quick review. A hydrate is an ionic compound that has water dissolved in its structure. So let's bring this back up. One example is copper nitrate. Copper 2 nitrate pentahydrate. Okay. For every 1 unit of the copper 2 nitrate, you get 5 units of water dissolved in its crystal structure. All right. So if you were to heat it up, you could drive off that water and be left with just the copper 2 nitrate. Okay. So those are what our hydrates are. So what you are going to, well, what you would ordinarily do in this lab is you would take copper 2 sulfate pentahydrate, you would dissolve it in water, and then you would react it with sodium hydroxide. Here, I'll bring this back up. So step 1, you dissolve it in water. Then step 2, you react it with sodium hydroxide to make copper hydroxide. Then you heat the copper hydroxide there in solution, and you're going to get copper oxide, or not in solution. The hydroxide comes out of solution as a solid. Sorry. You filter it, you get the copper oxide out. Okay. Okay. So what that would give you would be some amount of copper oxide. So you're going from copper sulfate pentahydrate to copper oxide. Copper 2 oxide, I should say. Obviously, this isn't a balanced chemical reaction. Fortunately, this is fairly straightforward because if you look, you see 1 copper sulfate pentahydrate produces 1 copper sulfate. Then 1 copper sulfate produces 1 copper 2 hydroxide. And then the copper 2 hydroxide, you heat it up, it decomposes, it produces 1 copper oxide. So 1 to 1 to 1 to 1 to 1 to 1. So if you have 1 mole of the copper sulfate pentahydrate, you'll produce 1 mole of your copper 2 oxide. So one of the things you're going to be doing is you're going to do a percent yield calculation. So percent yield is equal to your actual yield divided by your theoretical yield. Okay. Now, if everything went, you can't see what I'm writing. Okay. So if everything goes perfectly, then you would get your theoretical yield. Okay. So for one example, working with iron ore, you mix it with carbon, you can produce iron metal and carbon dioxide. This is just very basic metallurgy. This is how you make iron. So we balance this. And when you do the stoichiometry, you'd find that 10 grams of your iron 3 oxide, will produce a little bit less than 7 grams of iron. Okay. So stoichiometry tells us this. This is our theoretical yield. What if instead you produced, 6.5 grams? Okay. So that would be your actual yield. Your percent yield would be the 6.5 grams divided by the 6.9968 grams. Let me bring up my calculator. That's going to be half of 1/7, 1/4. It's going to be about 7%, I think. Okay. Yeah. Well, 92%. So 6.5 divided by 6.9968 equals, about 93% yield. So you only produce 93% of what you expected. Now, why would that happen? Well, that depends on a number of different things, but reactions can be incomplete. You can get side reactions, byproducts. You can get all sorts of stuff going on. No reaction is ever going to proceed perfectly. You're always going to have something less than 100%. A bad reaction could be, very, very low. A really good reaction could be very, very high, but never going to be 100%. So that's one of the things that's going to happen in this lab, is you are going to, you ordinarily would do this reaction. You'd get some amount of your copper oxide, and you would find the percent yield. And then you would go on to do that with other salts in order to, you wouldn't do it with other salts. You'd take an unknown salt, and you would do much the same thing. You would react it with the sodium hydroxide to get copper 2 hydroxide, and then heat it up to get copper oxide out of it. So then you could find out which of those reactions, which of these unknown salts it is. Is it the copper 2 sulfate pentahydrate, copper 2 bromide, copper 2 chloride dihydrate, copper 2 nitrate trihydrate? You got various options there. Okay. And based on your calculation of the percent yield that you got out of that reaction, you would then, you would then take it back and do the stoichiometry and find out, which one of these things is it? Okay. Because each of these, different salts would have different stoichiometry. You would produce different amounts of copper oxide. So this is, dang it, dog, don't hit my microphone. So this is a combination of percent yield and stoichiometry. So you do the stoich for each of these salts, and then you do the percent yield, and that would tell you what mass of products you would expect for each of those 4 salts. And thus, you compare that to the mass of products you actually got, and you would know which of the 4 salts it is. So just to make up numbers at random, because I don't want to do these calculations, say you have salts, A, B, and C. You do the stoichiometry, and your theoretical yield for A is, say, 2 grams. For B, it's 2.5 grams, and for C, it is 3.0 grams. And then, again, let's keep it as relatively simple. Let's say you have a 90% yield. 90% of 2 grams would be 1.8 grams. 90% of 2.5 grams is going to be 2 1/4. That can't be right. You're losing temperature. Oh, yeah, it is right. All right. And then for this, it's going to be 2.7 grams. All right. So you have these 3 very different possibilities. And you have your actual thing, the thing you don't know what it is. You measure it, and you got 2.68 grams, and you say, oh, that's really close to 2.7, so we're looking at salt C. Okay. So that is how you'd be doing this lab. Okay. Pretty straightforward, assuming that you've already covered balancing chemical reactions and stoichiometry in class. The only new thing here is percent yield, and it's just a slight complication. There's not really a heck of a lot to it, I don't think. So, good luck with this, and I will see you around.